Hello and welcome back to Atomic Math. Today we're going to look at vectors again. We're going to look at a little bit more detail. So to begin, a vector is a quantity that it has both size and direction. So some examples of vectors are displacement, velocity, and acceleration. Now in the previous video, I talked about displacement, how it was different than distance. And I showed how it was a vector. If you're struggling with vectors and you're watching this video, I highly recommend going back and watching the first video, which was called How Trigonometry Can Help Make Vectors Easy. I will put a link in the comments so you can do that, but again, I would recommend watching that one first. But I will do a quick little kind of review of the displacement thing. So basically what we did in the other video is we showed that if you drove in a bunch of different directions until you got to your final destination, your vehicle would give you a certain number of kilometers that you drove. But displacement doesn't care how far you drove or how long it took you to get there. It only cares about where you started and where you finished. So for displacement, that would be this vector here. It doesn't matter about all those other vectors. It just matters where you started and where you finished. And so whenever we have a vector like this, we can of course break it into its x and y components, which is what we were using trigonometry for in the previous video. So we know that the vectors can be described in terms of their x and y. For this video, we're only going to be talking about two dimensions, so x and y. I'm not going to talk about z at this time. So let's take a look at how we represent a vector. So vectors are represented by unit vectors. So a unit vector has a length of 1, but a specific direction. For the x-axis, we use the unit vector I. You can see it down there in yellow, and it has a size of 1, but it points in the direction of the x-axis. For the y-axis, we use the unit vector j. You can see that one in blue. Again, it has a size of 1, but it gives us the direction of the y-axis. And we can describe any vector in terms of these two unit vectors. So let's take a look at how we can do that. So we will make up a vector. We have this vector here. So this vector can be represented as 3 I vectors plus 2 j vectors. So our vector could be written like this: 3i plus 2j. So that tells you that you have to go over 3 and up 2. Let's take a look at another one. All right. For this one, we could say that this one is 1i and 3j. So this vector would look like this: 1i plus 3j. We can also add vectors together. So let's take a look at that. So here I have two vectors, a and b. So let's put them on the graph. There we have a, there we have b. Now, if we want to add these vectors together, there's two ways that we can do it. We can do it visually, or we can do it by its components. So let's start with the visual. So in order to do that visually, we just want to move one of the vectors so that it's head to tail. So basically it's kind of like our displacement where we started and we keep kind of moving forward. Now we can say that our vector is this here because we only care about where we started and where we finished. The vector it would give us, you can see you go over 5 and you go up 3. Now let's look at it how we would do it with components. So you can see vector A, vector B. I have 2 i's and 3 i's. I'm going to add those two together. Then I'm going to add the 2j together. So you can see here 2i plus 3i and then 2j plus 1j. So it's going to give me 5j plus 3j. And so we get the same vector, 5i plus 3j. And we can move our unit vectors down to show that. So whether we solve it through visually lining up our vectors or solving through components, it really depends on what you're given. If you're given vector equations, of course, it's just easier to just add their components together. But if you're not given an equation and you're just given a graph with some vectors on it, then it's easier to just draw them head to tail. So one of the things I want to point out is that the order in which you add them does not matter. It's very similar to just regular math. You can add things in any order. I can add 5 plus 6 plus 7, or I could add 7 plus 5 plus 6. It doesn't matter which one I do first. So let's take a look and just so we can see this visually. We have these random vectors right here. So let's move them into a path. So we're going to start with our green, then our yellow, then our pink, then our orange, and then our blue. So our resultant vector is going to be this one here. So let's just move that aside and we'll mix these up and we'll put them back in a different order. So now I'm starting with the yellow, then pink, then orange, then blue, then green. It's obviously a completely different shape, but you can see that it results in the same vector. And we can try that one more time just to be sure. We're going to put it into a different shape. Again, like I said, we're mixing up the order that we're putting the arrows in, but you can see that the resultant vector is the same. So it does not matter which vector you start with and which vector you finish with, as long as you've lined them up head to tail. So I hope that this helped sort of demystify vectors, or at least adding vectors together. I will probably do some more videos on vectors. Please let me know in the comments if you have any specific topics that you struggle with that you would like for me to cover. If you like this video, hit like, and if you want to see more videos like this, hit subscribe, and I'll look forward to seeing you in the next video.